Folks, welcome back. Section 11.4, Polar Coordinates, Part 2. Everything we're going to do in this part of Section 11.4 involves the four conversion factors between polar and rectangular coordinates. We have x equals r cosine theta. We have y equals r sine theta. The sum of x squared and y squared equals r squared, and then y over x equals tan theta. One thing we'll also do here is we'll kind of adjust these two to say that cosine theta equals x over r, and we'll say that sine theta equals y over r. And at this point you might be asking yourself, wait, Mr. Vast always warned us to never divide by anything that could be zero, and that is a true statement. And today I'm going to ask you to stretch yourself a little bit and maybe think outside the box. In fact, I'd like you to perhaps use an old Jedi mind trick.
Let me see your identification.
You don't need to see his identification.
We don't need to see his identification.
These aren't the droids you're looking for.
These aren't the droids we're looking for.
He can go about his business.
You can go about your business.
Move along.
Hold on. Hold on.
Folks, I want you to use some Jedi mind tricks here, and I want you to think about, just think about what might happen if you divide by zero. And there'll be times when I mention it throughout the video to say, hey, be aware here that you might be dividing by zero. And we're just kind of going to use a Jedi mind trick, wave our hand at it a few times and say, move along, and then not be too worried about it. But let's jump right into some example problems here. Number one, convert each equation from polar coordinates r comma theta to rectangular coordinates x comma y. So the front side of this, all of our equations are in polar coordinates, and we're going to convert to x comma y. And on the back side, the opposite is true. We're going to go from x comma y to r comma theta. So the first thing I'd like to do here with, and I've broken out each type of problem. So the first set of equations we'll look at are equations of circles. Second set we'll look at are equations of lines, and then just this other crazy one down here. Same thing on the back side. I've broken them out by families of graphs. So let's look at this first one. First thing I want to do is square both sides and get r squared equals 7. You might wonder, well, why are you doing that? How do I know to do that? We're looking up here at all of our conversion factors, and we're trying to turn r and theta into some version of x and y. So the reason why I squared both sides here, which is a completely legal algebraic operation, is because now I have x squared plus y squared on the left, because r squared is equal to x squared plus y squared, and then I have 49 on the right. So the equation r equals 7 in polar coordinates is x squared plus y squared equals 49. That's a pretty easy one for us to start with. If you have a radius of 7, the equation of that circle centered at the origin is x squared plus y squared equals 49. It gets a little more complicated as we move to part B and part C. So what we're going to do here is we're going to do a couple substitutions. I'm going to say r equals 6 times the cosine theta, which from my conversion factors above is x over r. And when I multiply both sides by r, I get r squared equals 6x. And right now I have a problem. I'm mixing r's and x's. We have to have everything be r and theta or everything be x and y. So I need to get rid of r squared. I can do that by substituting in x squared plus y squared equals 6x. Okay, now still have quite a bit more work to do on this one. What I have to do is I'm going to move this x to the left-hand side. So I have x squared minus 6x plus y squared equals 0. And my goal is to try to make this look like the equation of a circle, because I told you at the start that this was an equation that makes a circle. So if only I knew something to do over here where I have something that x squared minus 6x almost looks like it wants to be a trinomial, a quadratic trinomial. And what I'm going to do now is something called, and you probably haven't had to do this for a couple months, so don't freak out too much. I'm going to complete the square. And I'm going to complete the square on x. So in order to do that, I'm going to have x squared minus 6x. And completing the square, I have to take half of that x term, which is negative 3, and then square it, which is positive 9. If I add 9 to the left-hand side of the equation, I also have to add 9 to the right-hand side of the equation. Okay. And what I've done there is completely legal. I added the same thing to both sides. The reason why I did that is because the thing in parentheses here can be simplified to x minus 3 quantity squared. And I still have plus y squared, and that equals 9. So if you recall from your work in Algebra 2 or geometry, that is the equation of a circle centered at 3, 0 with a radius of the square root of 9, or 3. All right, this next one here, part C, I'm going to go through that pretty quickly. It's also going to involve completing the square, except this time it'll end up being on the variable y. Okay, folks, r equals 9 sine theta is a circle that can be rewritten in x comma y as x squared plus the quantity y minus 9/2 squared equals 81 over 4. And if you're not sure where the 9/2 or the 81 over 4 come from, in order to complete the square on y squared minus 9y, I have to cut negative 9 in half and then square it, and that gives me my 81 over 4. Okay, let's move on and look at some linear equations. So if I have an equation theta equals 5 pi over 6, I want to convert this to x comma y, and I do have a conversion that involves theta, x, and y right up here. It says that the tangent of theta equals y over x. So I'm just going to look at the tangent of each of these angles and see what I can come up with. So I have the tangent of 5 pi over 6. So that's sine over cosine. The sine of 5 pi over 6 is 1/2. The cosine is negative root 3 over 2. So that's going to give me negative 1 over root 3. You might have to think through that a little bit more, perhaps even sketch it out on paper, but unless you've memorized all the tangent ratios, you're going to have to come up with that on your own. Okay, now I'm ready to write this as y over x equals the tangent of theta. Okay, so in this case, I know y over x has to equal negative 1 over root 3. If that root 3 in the denominator bothers you, feel free to rationalize it. Now, to get this as y equals a function of x, I'm just going to multiply both sides of this equation by x, and I get y equals negative 1 over root 3 times x. And that is a linear equation. The slope is negative 1 over root 3, and it happens to go through the origin. Okay, let's move on and do example E. Theta equals 7 pi over 4. Well, that one was pretty quick. Not too much to do to add to that one. Let's move on to this one down here. This one's going to sting a little bit, folks. It's pretty complicated, and I'll just tell you that your final answer for this one, it's not going to be y equals a function of x like we had for these two linear equations. It's not even going to be nice like these circle equations. Okay, now I notice I didn't say these circle functions because the equation of a circle is not a function. But it's going to be kind of messy, and there really is no perfect way to simplify this, so I'm going to leave it in one form, and your form may look a little different, but it could be equivalent. You're just going to have to kind of know what to check for equivalency there. So let's start by saying r squared equals 4 times, well, I've cosine of 2 theta. Remember the double angle formula for cosine? There are several, but let's just go ahead and use the one that's cosine. That's going to be 2 cosine squared of theta minus 1. And that's what I'm going to use for my substitution here. So I have 4 times 2 cosine squared of theta minus 1. I'm going to go ahead and distribute that 4. So that gives me r squared equals 8 times cosine squared theta minus 4. And now I'm going to substitute in what I know. I know r squared is x squared plus y squared. And I know that cosine of theta is x over r. I have to square that, and then we have this minus 4 out here. From here, there's not a lot left for me to do. I have on my left x squared plus y squared equals, over here I'm going to have 8x squared over r squared minus 4. Now, I have to turn this as an equation from r comma theta to x comma y. So I'm not done yet because I still have an r squared in there. So what I have to do is my final substitution, x squared plus y squared equals 8x squared over x squared plus y squared, and then subtract 4. I'm going to call that my final answer. If you really wanted to, you could multiply both sides by x squared plus y squared to clear this denominator out. But that really doesn't add much value here. I have no idea what the graph of this function looks like. We could talk about that later in class when we learn how to use our calculators to graph polar equations. But for now, we just know that we've been able to turn it from an equation in r theta to x comma y.